Hi guys, it's Mrs. Millison. Okay, last video for this chapter, okay? We need to be able to prove that events are independent, okay? And we're gonna use that, we're gonna do that by using conditional probabilities, okay? So I have this on our little cheat sheet here, okay? We prove two events are independent if the conditional equals the probability of the event happening without the condition. Because if that happens, then the two events are independent, which basically means event A will happen at the same probability and B has no impact on it whatsoever, okay? So we say probability of A given B equals the probability of A. Then the events A and B are independent. And you guys know proving two events, two variables are dependent or independent is a very important concept in statistics, okay? Proving that there's a relationship is very important, okay? So I want to think through this algebraically. Okay, from our cheat sheet, let me write it down. A given B equals the probability of A. From our cheat sheet, we know the probability of A given B is the probability that A and B occurs divided by the probability of B. Okay, so we know that this is the probability of A and B divided by the probability of the condition. Okay, well, if A and B are independent, then we can calculate the and by simply calculating the probabilities. Okay, so if A and B are independent, the probability of A and B is simply the probability of A times the probability of B. Well, if I divide that by the probability of B, algebraically these cancel. So of course it'll equal the probability of A, okay? If A and B are independent. So A and B are independent events, which means there's no relationship, no association between the events, okay? So that's how I think about it algebraically. Let's prove it. Let's do an example here. We have some information about 100 people. They were asked what their dominant hand was, left or right, and then they were categorized by gender. So we're going to do a couple of these calculations to prove if gender and hand domination or dominant hand are independent, okay? Just like in chapter 1, if they're different, it equals dependent, okay? If they're equal, they're independent, okay? So if these numbers are different, they're going to be dependent. Okay, so let's just do a couple. And it doesn't matter what you pick, because if variables are independent, they're independent. If they're dependent, they're dependent. It doesn't matter what you choose. I'm going to choose the probability that a person is male given that they are right-handed. So if this equals the probability that somebody is male, then I can say gender and dominant hand are independent, okay? So back to my conditional distributions, okay? I'm going to read this as, of all the right-handed people, 90, what proportion are male? 39. Or I can think about this as and over the condition. Male and right-handed is 39 over 100 over the condition, which is right-handed, 90 over 100. I'm still going to get 39 over 100, which happens to be 0.43. Okay, now if this equals the probability of being male, then these events are independent. Okay, so the probability of being male, that's just a straight marginal distribution. That's just 46 over 100. And that's 0.46. Now, I don't know about you, but 0.43 and 0.46 are not equal, okay? I don't care that they're close, they're not equal, okay? So this is different. This means gender and dominant hand are dependent, not independent, okay? Remember, different equals dependent. If they were equal, then they would be independent, okay? Let's just do one more example, just so you can see. I'm going to flip it. Let's do the probability that somebody is left-handed given that they're female, okay? So again, if this is equal to the probability that somebody is left-handed, it means being female doesn't matter. It has no impact, okay? They're independent. Probability of left and female, Left and female is 3 over female, which is 54. I'll do the decimals in a second. And the probability that somebody is left-handed is 10 over 100. Again, a marginal distribution. So 3/54 is 0.05, and of course this is 0.1. Definitely not the same, okay? So what we have here is we have proof, okay, or we have some statistical evidence that gender and dominant hand are not independent. They are dependent. There is some sort of relationship. So I'm going to write gender and dominant hand are not independent. Oops. There is an association between gender and hand dominance. Okay, so again, we started talking about this concept of proving independence back in chapter 1 when we did conditional distributions, and if they were different, they were dependent. If they were the same, they're independent. And here we are back again with the same concept, but this time using probability. If they're different, they're dependent. If they're equal, then they're independent. Okay, and we'll see this concept yet again when we get to chi-square tests. Okay, I hope this was helpful, and I will see you all next time.